Hi guys, in this problem we are going to work through a thermochemistry practice problem that draws together a lot of the key concepts that we've been talking about thus far. So in this problem we're given a glove and we're given the mass of that glove and a temperature change that's associated with the absorption of a certain amount of energy. And we are asked to determine what the specific heat is of that glove. In other words, what the specific heat is of the material that the glove is made out of. And then we're asked to use that information along with the information provided below in this table to come up with a guess as to what that glove is actually made out of. So the first step then in this problem is to go ahead and run through all of the given data, which is of course our mass, the delta T and Q, and notice I'm being very careful to include the units, the given units for each one of these quantities, and then write down what it is that we're expected to find. So in this case, our goal is to find that specific heat of the glove, all right, the material that the glove is made out of, typically denoted by C. So what we need then is a relationship. In order to solve this problem, we need a relationship that relates all of these given values with the desired value, the value we need to find. And so hopefully at this point you guys will recognize that the relationship that we're going to be applying here is the so-called Mcat equation, Q equals mc delta T, or the energy, right, required associated with a given change in temperature is related to the mass of or amount of quantity that you have multiplied by this term that's specific to the substance in question, which is our specific heat. So our goal in this problem is of course to solve for the specific heat, so we're going to do a little algebra and we can rearrange and come up with an expression that tells us what the specific heat is given a Q, M, and a delta T. Now, here is one of the most common mistakes students make in a problem like this. At this point, what many students will do is go ahead and use all of these given values, plug them directly into the equation, and then come up with an answer, compare it to the values in the table and move along. Okay, so let's go back at that table to see why this is not the way that we should proceed. Okay, so notice, look closely here. We are going to be comparing with specific heat values, tabulated specific heat values, and the units of those specific heat values are joules per gram degrees Celsius. Okay. Now, if we look at the units that we're given, it's grams, degrees Fahrenheit, and kilojoules. Okay? So before we can plug things in to this equation, we're going to have to stop for a second and carry out some unit conversions. Okay, so the unit conversion steps, well, for mass, nothing's needed to be done. All right? The given values in grams, the desired values in grams, we're good to go. However, both the delta T and the given energy must be converted to the desired units here. For the first one, we're given a value in degrees Fahrenheit, and we need to convert that delta T into units of degrees Celsius. With energy, we're given a value in kilojoules, and we need to end up in joules. Now, the second one is pretty straightforward. We don't really need to spend much time on that. Hopefully, you guys are nice and comfortable at this point doing a conversion from kilojoules to joules. We all know that 1 kilojoule is equal to 1,000 joules, so we can quickly capture that using scientific notation here. Okay. Now, the delta T gives us a little bit more trouble. So hopefully, once you see and you realize that you have to carry out a unit conversion involving temperature, you'll no doubt recall the relationship for relating different absolute temperatures and from degrees Fahrenheit to degrees Celsius. So that's this relationship at the bottom of the screen right here. Now this is essentially the second most common mistake that students will make. For those students that tackle the first hurdle, realize they need to convert units, a lot of times I will see students providing this relationship directly to our given delta T and deriving an associated delta T in degrees Fahrenheit from this equation. Now, that also is going to give you the wrong answer. To appreciate why, let's go ahead and work out the details. Okay, so let's think about what we have here. When we are given a delta T in degrees Fahrenheit, well, first off, let's draw our attention to that fact. I'm going to use a superscript up here to denote the units that the given value is in, just so we can keep track of what's going on here. So that delta T is a final minus initial, and the units are, of course, degrees Fahrenheit. Okay, so we effectively have two different temperature measurements that are contributing to this delta T calculation. And for each one of those temperature measurements, we can apply our equation up top. So the first equation, I'm going to put a red circle around this term. That is going to show up right here. And the second equation, we'll do a nice pink circle, is going to allow us to re-express this initial temperature. Okay, now once we've plugged in the temperature values in degrees Celsius, some nice things happen. So notice we have a plus 32 here, but then we also have a minus plus 32 over here. So the 32s are actually going to cancel out, and we can factor out the 9/5, and what we're going to be left with then is the final temperature in degrees Celsius minus the initial temperature in degrees Celsius, which of course can be more compactly represented as just a delta T in units of degrees Celsius. So this has given us a nice simple equation. Delta T in degrees Fahrenheit is equal to 9/5 times the delta T in degrees Celsius. So notice that scale factor remains, but the offset up here initially, the offset of 32, vanishes. And so we don't want to include that in our calculation. So if we carry out the actual conversion here, we're going to set things up starting off with what we're given, a delta T in degrees Fahrenheit. We know that's 25.9 degrees Fahrenheit. We know based on our previous work that that's equal to 9/5 times delta T in degrees Celsius. And so our delta T in degrees Celsius is going to then be equal to 5/9. Just doing a little algebra here, solving for delta T in degrees Celsius, 5/9 times the temperature change in units of Fahrenheit. So plugging in that value, multiplying by 5/9 gives us a temperature. And now we can plug that value of 14.4 degrees Celsius back into our initial Mcat equation. Recall that we solved for C. We get Q over M delta T. We're going to plug in our Q in units of joules. We're going to plug in our mass in grams. And we're going to plug in the delta T on units of degrees Celsius. And we're going to arrive at our final answer, 1.36 joules per gram degrees Celsius as the specific heat for the material of the glove. Now, our final problem, the final part of the problem, it asks us to use the tabulated values reproduced right here in order to identify the unknown, or at least come up with a good guess. Okay, so if we compare 1.36 going down this list of given specific heats, well, the first thing to notice is that, of course, it doesn't match up exactly with any one of these guys. So what we're going to end up doing is pick the one that is the closest match. And in this case, the wool felt is our best candidate. So that would then be our hypothesis. We would hypothesize that this glove is made out of a wool felt material. Now, of course, this is a necessary but not sufficient condition for identification of material. That is to say, if the heat capacity that you calculate here is nowhere close to the specific heat of a known substance, then you can definitively rule that out. However, just getting a close match like we did right here does not definitively say that we have wool felt. There could be any number of other materials that have a very similar specific heat.